Okay, let's now continue very quickly with the binary tree. So we talked about all the necessary concepts for binary trees on Tuesday. Let's see very quickly how you can implement that. The idea is very simple. Basically, for every node in the tree, we're going to make two references. One is to the left, the other one to the right, which might be null, which means the subtrees might be empty, right? Okay, let's see how we can do that. You'll find the code very similar to how you implemented a singly linked list. In some way, it's linked structure, okay? Now, this is the most critical attribute you should know. So we simply call that BT node. BT stands for binary tree. Binary tree node, every node is actually BT node. So we got, let's say we store strings only for now. You can have string A, B, C, D, etc. So we got string elements, a little bit like a data element, what you had in a singly linked list. And then you can see we got left and right. And the types are simply BT node, pretty much like a singly linked node as before. Okay, we got two references. And then when we first initialize a new node, we simply pass, sorry, there's a typo there. It should be just element here. Okay, if you check your source code, it should be just element, no key. Okay, so I'll fix that. So it should be just element here, and then we just initialize the element for the node. I'll give you an example in just a moment. And then you can have accessors to get the elements, get a left and get a right. Notice that the return type for get left and get right, they're both BT node, just returning another node. And also we can set the elements and also set the left and set the right. Very similar to set next and also get element, get next, what you had before. Okay, let's see how we can declare binary tree. What we just said was just about how you can do a binary tree node, and now we talk about binary tree. For each binary tree, we have just a single node, which is the root. And then the constructor is very simple. We simply do nothing. What does that mean? That means the root is going to have the default value for reference variable, which will be just null. So that means empty tree means the root is null. And then we can set the root to be any node we like. Okay, we'll see that in just a moment. Okay. Now, how do we add nodes? Let me just go over some basic operations with you, and then we'll see one example, and everything hopefully will just be clear. Now, let's say we have the same binary tree class. Remember, we have a root. Let's define two add operations. Very simple. Now, when we say add to the left, which means give me any nodes on the tree, any nodes. Given that the node is on the tree, and then we're going to store to its left another node, and then store element inside. Okay, that's kind of what it means. And then we just make sure the node itself does not have the left already. If it does, you're going to throw some illegal argument exception. Okay? Otherwise, you'll simply say the node does set left, and then just create a new node. I'll show you one example in just a moment, but let's go over these two methods. And the next one, you can also add to the right. Again, give it any node, presumably in the tree, and then you can add to its right a new node, which store the element string over here. Okay, similar code structure here, and then end up set right over here. As you can see, these two methods here are not recursive. Okay, they are not recursive, so they should be very simple. It's pretty much like an add to the first, add to the last, like what you did before for the singly linked list. Okay, so and then we just pass in a reference of the node for each parameter. Okay, let's do one exercise together. Let's say I would like to initialize this binary tree over here. The root is simply D, the node storing D. And the left of the root is a node storing B. The right of the root is a node storing F, okay, and etc. So now, first of all, let me just say something here. Let's say I talk about the root. When I say root.getLeft, I should really get this node. When I say root.getRight, I should get this node over here, storing F. How do I get to node A? Get left, exactly. Okay, just as simple as that. Okay, now let's see how we can set up this tree structure. Again, the source code is available to you. You should really play with that. Okay. Now, first of all, we create a new binary tree. The binary tree initially has the root being null, empty. And then let's create this root node over here. And then we'll say, create a BT node over here, which being the root. And then we say there's a new BT node storing D. Okay. But so far, you can see that this node over here called root, it has not become the root of the tree just yet. We haven't built any connection. The way to build a connection is we're going to say BT, the binary tree, does set root to be that particular root, the node. Okay? After this, we are making this connection here. The root of the tree is pointing to the node D. Okay. Now, what's going to be the left? What's going to be left for us to do will be how can we set the left of D to be a node storing B, and the right of D to be a node storing F, and etc. Okay. Now, let me just show you one. Question. Yes, let's say if the root is already there, you can, yeah, exactly. Very good. I'll try to upload the slides so that you get that. Okay. The question was, if the tree already has a root in this line over here, then of course there will be a legal argument exception. I'll add that to the slides. Okay. Now let's see over here, you can say now, this is how you add to the left. You can see BT, which is the binary tree, add to the left. I want to add to the left of the root, which is this node over here. And then add to its left and storing B. What it will do is, it's going to create, let me just show you just one example over here. Okay, let's just go over there. Okay, let's see how we can do that. First of all, we already have a tree like this. So let's say we already got a tree which has the root pointing to a node that stores D. Okay, now what does it really mean when we say BT dot add to the left? And then I want to say I want to add to the left of this particular root over here, and then I want to add another element storing B. Okay, so what would that involve? Okay, let's again review very quickly how the add to left is doing. It would simply say if the node I'm trying to add to the left to, in this case the root, if it already has a left child, it will be a legal argument exception. In this case, no, right? It does not have a left child already. Okay? So what we will do is we're going to say n.set left and then a new node. I'll show that to you. So what we will do is we'll say root in this node here dot set left to be some new node. New and then BT node over here and then just the elements, right? In this case, that will be B. Okay? So now let me just highlight that. Let's do this step first. New BT node B. So what does that mean? That means I'm going to first of all create a new node over here storing just B. That's the first step. And then the second step, I'm going to use a different color here. It's root.set left. I'm going to make some connection over there, right? So that means I'm going to say, again, different color here, root over here dot set left to be this node. Okay? Guys, is it clear? So you do the similar thing to build out the tree. Okay, let me just go over the rest very quickly. Now let's go back there and see what we did. Okay, that's what we did. So set add to the left and then root and B. How do I set this F over here? Add to the right, exactly, and then root and then F. Okay, one more exercise. How do I add A over here? Add to left, so you're going to pass something here, right? Remember there are two parameters you're going to pass. For sure, the second parameter should be just A, right? I'm creating A. Now, which node I'm trying to add the left to? B. In this case, B will be root that get left. Agree? So that's exactly what I did. Okay? That's one way to do it. Okay? Similarly, how do I set up F? Well, I simply say add to the right and then C. Okay? And then hopefully you see the idea. Build up the rest. Okay, any questions about this? That's the basic operations. As I said before, I decided not to cover binary search tree for this course because you will learn about it in 2011. So if you got any trouble with this, let me know. Okay? That's the most basic structures you can build. Okay? Pretty much like a linked list. Now we actually covered this already last time. How can you figure out the size of a binary tree? You can calculate this recursively. So this is the idea. Size of a tree rooted at R is going to be 1 plus the size of the left subtree plus the size of the right subtree. That's exactly what you do. Okay, you can refer to how I illustrated from the last lecture. Now, how do we do that in Java? Very easy. So now, the only thing I want to point to your attention is, so now let's say we want to define this method here called size which itself does not take any parameter. But now whenever you want to do recursion on the tree, similar to the case of the array, you want to have some recursive helper method. In the case of the array, we got a from and to indices. Now, in the case of the tree, we just need to have what's the subtree, what's the root of the subtree you're talking about. Okay? For example, let me just give you one very quick example here. Let's say over here, if I want to figure out what's the size of the subtree that's rooted at D, the answer should be 1, 2, 3, 4, 5, 6, 7. Should be 7. The way I calculated that recursively is by saying over here. So now, let me just put it here. What's the size of the subtree rooted at D? The way I can define this is by saying the following. I'm going to call the helper method. I'm going to say size helper. And then, in this case, I'm going to say it's going to be the size helper, and then I'm going to get D dot left. Okay? I want to know what's the size of this subtree here. Tell me. And then, plus, that's called the size helper again, and then D dot right. Right? That's a standard way of doing recursion on the tree. And then, tell me what's the size of this subtree here. Figure that out, and then plus the node itself. 1. Okay? So now, as you can see, what we can expect from the recursion, which we can assume, the size is going to be 3 for this subtree here, and it's going to be 3 for this one here. 3 plus 3 plus 1, I'll get 7. Okay? That's the idea. If you go back to the code, that's exactly what happened. We have size helper over here, and then the root to begin with. And then we can simply say if the root is simply null, that's empty, just 0. Otherwise, we can just say 1, the node itself, and then on the left and on the right. Okay, that's how you do recursion. Any question on this? Are we okay? Yes?
Is it necessary if we do it, like, let's say every time we add, the way we add a sign, a global method called size?
You mean a global attributes called size? Yes, that would be, the question was, rather than calculating the size of the entire tree every time, can we do what we did for simply linked lists, like a size attribute? Yes, indeed. So here I didn't do that because I want to illustrate how you can calculate the size recursively. Yes, you can do that. Yes. Mm-hmm. Okay, now you can just run some JUnit tests. I'll leave that to you. For example, you can just build the tree as we did before, and then you can see that the size should be 7. Okay, that's how I calculate it recursively. Okay, that's JUnit test you can go over. And membership, I want to check if an element is in the tree. Also, we covered that already. It's either the element is already on the root itself, or the element might be on the left subtree, or it might be on the right subtree. Right? That's what we said before. And that's exactly what you do. Again, you use a helper method over here, which will have the root of the subtree you're considering, and also the element you're searching for. And then this is how we do. If the root is simply null, that means there's no way for the empty tree to contain any element, so just return false. Otherwise, we're going to say either the root.getElement is already the element we're searching for, or it's going to be the left subtree that contains the element, or it's going to be the right subtree that contains the element. Okay. Guys, are we okay with this? Okay. In case you're puzzled, I will give you a little bit review. Remember what we talked about last time. I think you can review, that's exactly what we said last time, how you can compute recursively. Just that we didn't say Java code last time, but concept is really there. Okay, that's something you can review from last time. Okay, good. Now, the membership, you can also check to see if something's there. You can also see the JUnit test. I'll leave that to you also. Okay, one more thing. How do we do traversal? So we learned about conceptually how you can do the 3 kinds of traversal in order, pre-order, or post-order. Okay, again, let's see how the Java code, how closely it will correspond to your concept. Very close. Let's say now we use, again, we are in the binary tree. Let's say we want to support a method called in order. Okay, and now what this will do is, let me just show you one use case. Okay, now for example, let's say this is a tree I have. It's called BT. For example, if I say BT dot in order over here, okay, so this will return an array list. That's the return type. Well, what does that mean? That means it's going to return, I'm just going to draw array shape. It's going to return to me a sequence of elements that correspond to the in order traversal. In this case, it's going to be A, B, C, D, E, F, and G. It's going to be the array list that will be returned when I say whatever binary tree it is and then in order. Okay? But how do we calculate that? Okay? It's very easy. Basically, we're going to do the same before. You're trying to do in order traversal on the left subtree and then try to add the root into the array list and then do the in order traversal on the right subtree. That's what you would do. Okay? Let's see. Very simple. Now, again, so here we say that initially the list is simply just empty, storing a string. And then we're going to have some helper method to say the root, again, is the root of the subtree that we are currently considering. And then the list we're going to pass by reference, which means we're going to modify the same array list throughout all the recursive calls. You're going to modify this list one by one. And then eventually return the list. But now let's see how the in order helper can be defined. That's a recursive method. Now, let's say we got this. So usually you make the helper method private. You don't want to make them available. You only make the overall method public. That's usually the practice. And then in order helper here, this is the root of the subtree we're considering and also the list we are trying to accumulate one by one. Okay? Now let's see how we can do it. Remember the principle for in order. Left subtree, root, and right subtree. You will see that first of all, if the root is not equal to null, if it is null, nothing to do, empty list. Okay? First of all, we do call in order helper over here and root that get left. So now we do in order traversal on the left subtree. And then we add the root that get element into the list. And then we do the in order traversal on the right. That's it. Okay? How do you verify that your code is correct? You can write a JUnit test. We just add the same tree as we did before. And then if I say list is assigned to bt.inOrder, what I would get is I can now see exactly this order, what I talked about before, A, B, C, D, E, F, G. Okay? Guys, any question about how to define this? Are we okay? And you do exactly the same thing for the other traversal. Okay? Pre-order traversal, you can see that the only difference is we add the root first and then do pre-order traversal on the left and then pre-order traversal on the right. Similarly, for post-order over here, swap the order. We do the root first and then left subtree and the right subtree. Just the order, just swap the order. That's the only difference. And that will, you can see the JUnit test, and that reaches the end. Any question about binary trees? I tell you this, okay, for the final exam, we haven't confirmed yet. So if we decided that we're going to have a common exam, which means all the 3 instructors will contribute to the questions. In that case, I will try to see if they will ask a question about that. If they do, I will give you some extra resources to tell you how you can prepare. If I'm going to give you just the exam myself, I wouldn't put any complexity questions. I only test you what I teach. Okay? But we'll see. And it's still got to confirm with Burton and Matthew. Okay. But any question about what I have taught so far about binary trees? The reason, I tell you what, the reason that I'm teaching so fast, which I don't normally do, is because I don't think binary trees are important for this course. But I need to teach it. Any questions? If no, I will now enter the final topic for the course, inheritance. But it's a big topic, of course, very big topic. Okay, now don't be too terrified by the number of slides for that. Oh, don't worry, it's an animated version. You only got 79. It's not 700, don't worry. It cannot be. Okay. Now, inheritance, the reason that I think that's really important is we're going to learn lots about inheritance here. What you might have known from 1022 is at the superficial level, about how to do code reuse, which I'll talk about just today. Starting from next week, I will tell you the detailed story about polymorphism, dynamic binding, abstract class, interface, and generics. Okay? I think you deserve to know all the details. Otherwise, you have no chance to learn about these topics until 3311. That will be too late, I would say. Okay, now let's talk about inheritance. Today will be a little bit light, but I would suggest get yourself familiar with the example. We're going to use that throughout for next week. Okay, let's talk about this example. In case you haven't got a chance to look at that example, can we have a read very quickly? Okay, I'll give you 1 minute. Okay, have a read. I hope you see that I highlight all the important things for you, right? Yeah. Okay, let me summarize what's really important here. Yeah, questions or? Go ahead. Yeah. Uh-huh. It's only for methods. The question was, when you have the add override in Eclipse, that only applies to methods, which we will talk about actually. Yeah, maybe save that question for a little bit later. Okay, so guys, let me summarize very quickly about this problem here. Okay, so basically, we are trying to store a collection of students. However, there are two kinds of students. One kind is called resident students. The other kind is called non-resident students. Resident student means they live on campus, so we have a different way to calculate their tuition. We're going to apply whatever they got to pay with some premium rates, for example, 1.5. They're going to just pay more. The other kind of student called non-resident students. They don't live on campus, so their cost will be slightly less, so we're going to apply something called discount rate. In that case, maybe it can be 0.5, 0.75, something like that. Okay, it's an oversimplified version of reality, of course. And now, for both kind of students, they got something in common as well. They have the student, they have name, they have the list of courses they are registered, and also got the number of courses that's recorded, right? And then, also given any student, you want to calculate what's their tuition. Let's say this. Let's say we got two students here. Let's say Jim and Jeremy. Jim is a resident student, and Jeremy is a non-resident student. Jim has the premium rate 1.5. Jeremy has the discount rate 0.5, for example. In this case, if they are registered in the same course, let's say 2030, which costs, for example, $1,000. In that case, for Jim, he will pay more, like $1,500, because of the 1.5 premium rate. For Jeremy, he only has to pay $500 because of discount rate. Okay, that's kind of the issue we're dealing with. You just got two kinds of different students. And then, how do we actually store all these two kinds of students, objects, in a single system? That's a challenge, okay? Now, your task would be, I hope you maybe at least try mentally in your mind how to do this. We want to create Java classes for this problem here, okay? Let me give you a possible design, given that if you didn't know about inheritance, that's absolutely fine, okay? I want to give you a first design, and let's criticize about it together, okay? So let's try the version without the inheritance. And by the way, the source code is also available on the web. You can also try. I'm going to demonstrate some points using the code in just a moment. So now, let's say we don't have any inheritance. We just create different classes. In this case, it would make sense to create one class for resident students and the other class for non-resident students. Okay? And then also maybe one class for student management system. Okay? Let's see how that would look like. Let's say we have a class called resident students, in which case we know that each student has a name, and also a list of registered courses, and also number of courses. You should be very familiar with this pattern here, right? Okay, I don't need to say too much. And then, the resident student has something very special, which is not common with the non-resident students, which is the premium rates, which can be 1.1, 1.5, etc. And then, for resident students, to initialize that, let's say we just give a name of the student, Jim or Jeremy. And then initialize the name and also create the courses. Let's say up to 10 courses. I know in the previous slide say 30. I'll change that. 30 is actually not realistic. Maybe 10. Mm-hmm. And we can also register a course for this student here. Pass a course object aggregation. Okay. So now we can say that okay, you know pretty much the implementation for that. That's easy. And then we can also get the tuition for students. Now let's see here. When we say the tuition is initialized to be 0 and go over all the courses that this current student is taking, And then we simply accumulate and add up all the fee for all the courses. Up to now, we only compute the so-called base amount. We haven't applied any premium rate just yet, but up to now, just base amount. And then the next step would be, we say, return tuition multiply premium rate. So far, so good? Now, question for you. If the next slide, I'm going to present to you the class for non-resident students, would it be very different or very similar? Huh? Almost the same. Tell me something. What would I have to change? You can see that's exactly highlighted in yellow, right? Hopefully you see that. The class, yeah, you got to change the class name, you got to change the attribute name, but pretty much the same. Okay, hopefully you realize that. Let's try. Again, we got non-resident student here, just the other kind of students. We got name, registered courses, and number of courses. You can see we got repetition here. Okay. If you ever want to learn about design, maybe for later, I can tell you number one, design principle. Whenever you got repetition, that means your design smells. You want to get rid of that smell. That's how people say. Okay? We'll see how you can do that by using inheritance in just a moment. So you can see that's already repetition. However, this guy here, discount rate, is not really repetition. It's actually correct because discount rate is only applicable for non-resident students, but not resident students. And then we also got the constructor here, even though the name of the constructor is different because they're different classes. But you can see the body over here is really the same. Okay? We also initialize the name, also the constraint on the number of courses you can take is also the same. And then we say register, completely the same. That's how you register a course, by using aggregation. And then the way you get tuition, not exactly the same, but I would say almost the same. The way you calculate the so-called base amount is the same. Just go over all the courses and accumulate the amount for the base. And then the only difference is you're going to apply the discount rate at the end rather than premium rates. Okay? Any questions until now? Are we okay? Good. And then let's go on. Now let's just do a little bit of test. So not really JUnit test. I'll just try to use some tester, have some output to get some feel. Let's say we also got a course class over here. We got title and we got fee. And then initialize the title and the fee for the course. Okay, just make it simple. Let's say we have something called student tester here with a main method. Now, let's say we have two courses, C1 and C2, 2030, 3311. Let's say $500 each. That's the price before you apply any. Is it cheaper than in reality, or? Yeah. I'm pretty sure, right? Yeah. Yeah. I should really be more realistic. I'll try to change that price next semester or something. Yeah. Anyway, so now let's say we got these two courses here, and then first of all, we say that we got resident students. Jin is a new object of resident students, Jin Davis. And then Jin does set premium rate to be 1.25, okay? And then let's say we register Jin for both 2030 and 3311, let's say. Don't worry about the prerequisite. We just register these two courses. Now, take a guess. What's going to be tuition for Jin? $1,250, right? Okay, because 500 plus 500 multiply 1.25. Okay, I'll leave the math to you. Now, let's do another one. Let's say we also create non-resident student Jeremy, and then Jeremy Gibbons, and then we say Jeremy does set discount rate to be 0.75. Okay, so you can see they are, and then we say they become classmates. So now they are registered in the same two courses over here, and now if I try to print out the tuition for Jeremy, what would that be? 750, right? So it's different. You can see even though we are trying to call the tuition on the same method there, but because we're talking about different classes and different kind of students, so the price will be different. Okay? That's what you will see. You can also try it out. Okay? Any questions?
Yeah.
Go ahead.
You have a set discount rate and set premium rate.
Uh-huh.
These are the two, these are the difference between our resident student and non-resident.
Pretty much, the main difference.
Why two classes? We can just have one double value rate, and that would be 1.25.
Okay, so the question was, so why not we simply have this? That's a good question here. Let me just repeat what the question was. So question was, what about we just have a, let's say conceptually, why don't we just have a class called students over here? And then, as you said, we're going to have maybe just
One single class for resident.
okay, how do you, first of all, how do you distinguish between the two kinds of students?
Rates.
Hmm?
Rates.
Just by rates?
Group has like 1.25%.
But you know, premium rates and discount rate might change over time, right? Yeah,
The thing is, if you don't hard code it, then I don't think there is like any value in having two separate classes.
But the thing is, okay, first of all, we know that there might be different kinds of students we're going to deal with. In this case over here, so we have only two kinds of students. In reality, we might have 10 different kinds of students, right? Let me give you a little bit idea. So I think what you may want to lead to a solution like this. Let's say in the student class, I have an attribute like this. Let's say is, for example, is resident students. Is resident student, let's say is of type Boolean. It can either be true or false, right? Now, in reality, that's a good question. Let me show you another hierarchy here. Okay, let me just go a little bit forward to show you. Okay, would this solution work in general? Would that be a good solution though? Let's see this. You want to make your code as simple and neat as possible. That's the principle, okay? Let me just go a little bit fast over here. I want to show you this hierarchy here, which will be a little bit more complicated. Just give me one moment. I'm getting there, I think. Actually, you know what? It's easier to go in this way. I want to go to this one here. Let's talk about this hierarchy here. I'll read it to you. Let's say now rather than having just two kinds of students, we actually got 4 kinds of students. What does that mean? Under students, we have either domestic or foreign students. Under domestic student, we may have domestic resident or domestic non-resident. And now, for foreign student, you might have foreign resident or foreign non-resident, right? So that means you may have to extend your previous solution in the following way. You might say it's resident or it's not resident. Is foreign and also it's not foreign, right? So that's also Boolean. But think about how this is going to work when you're trying to use it, okay? Now, let's say this is a supplier side. This is how you define your classes, okay? Now, let's say how do you use it? The way you use it is when I declare some object over here, students, and then I say S is over here, right? And then I can set the Boolean attribute. Maybe, let's say now I say true and true, which means this particular student instance is a foreign resident student, right? Now, let's say over here, I pass this student object to some other methods, okay? I say some other method over here, and then I pass simply S, call by reference. Now, think about how this method here is going to define, okay? Because over here, we have S over here, which can be either of the 4 kinds we just talked about. So now how do we distinguish? So all you're going to say is, and over here, you're going to say something like this. If S dot is foreign, I'm going to do something here. And under is foreign, and you're going to say if S dot is resident. Right? To really distinguish between the 4 cases and else, right? Okay, I don't have space, but you can see the case. You need 4 cases, right? It's not very good. It will make your client's code too complicated. As you will see, if you try to use inheritance here, you actually get a much simpler code structure. This kind of a structure here, which you want to check which kind of student you're talking about, rather than using Boolean variables here, if you use inheritance, it's going to be done implicitly for you. That's why we're going to talk about polymorphism and dynamic binding, but we'll get there. Okay? So guys, basically, it was a good question here. I think if you review the lecture, the original question was, rather than creating 2 classes, why don't we simply use different Boolean variables over here to distinguish between the students? So depending on how you categorize the students. But now, in general, this solution wouldn't work very well because for any user who wants to use the student objects, they have no idea what kind of student it is until they write a nested if-else structure like that in their code. If you have 10 kinds of students or 20 kinds of students. In that case, your code structure is going to become very complicated. That's not the way to go. It might work, but it wouldn't scale up to a big projects.
It's not future-proof. If I have new class of students, what would that?
Yeah, exactly, right? Okay, guys, let's continue if you have no questions. But that was a good question, that one. Okay, let me just go back to where I was, if I can remember. Over here, right? Okay, now let's go back to the original design. We got two classes over there. Now, so here, the original design was we got non-resident students and resident students. What we saw was we got lots of repetition over there. Okay, let's see, first of all, if you try to run a tester over here, the code seems to work. They seem to be working. However, is it really good design? Okay, so another design principle is think about the future, which means your software project is not going to end once you submit it at the first time. It might be extended, right? That's an issue here, okay? So now let me give you some idea. You will learn more about this kind of design choices or principle in 3311 later. But I'll just give you a flavor. First of all, the code structure for the two student classes share a lot in common. So first of all, the design smells, okay? And then, so duplicate code is not a good option for design, okay? We're gonna change that. Also, think about this. Let me give you some idea. Let's see the slide, and then I will show you that in the Eclipse. Let's go back to this class over here. Let's say for register. You see over here, for the register here, remember the register method for resident students and non-resident students, they're completely the same, right? So we got duplication in two places because we got two kinds of students. Now, if we got 10 kinds of students or 4 kinds, we're gonna repeat the same register method for that however many kinds of students we have, right? For that many times. Now, thinking this way, let's think about the future. Let's say if in the future, let's say we change the registration policy a little bit. At the moment, we simply just allow the student to keep registering. Even if they have already registered 10 courses, they will just keep going until they actually got some array index out of bound exception, right? Okay, that's the current way of how the things work. Let's say we now decide to change the policy globally for the students to say, well, if you currently already register for 10 courses, in that case, I'm going to throw some illegal argument exception. Otherwise, I'll do what I did as before. That's a new policy. How many places do I need to repeat this new policy? In this case, 2, right? 2 means multiple, not just one place. So this design choice over there, which is called, I'll show you, I'll just write it down. You'll learn more about it in 3311. I'll just mention that. There's a design principle there called single choice principle. Single choice principle. So what single choice principle means is when there is a change, there should be only one place to change. Only one place. One place, I can say one place. The place can be either one single class or it can be a single method to apply the change. Okay, that's so something called single choice principle. Okay, we'll see this quite a few times before the end of the semester. Okay, so now, when you violate the single choice principle, what does that mean? That means if I want to apply a new change to my software, I need to change either multiple methods or multiple classes. In this case, I do violate the single choice principle. Let's go back again. Let me again show you that over here. Let's just go back to show you some Eclipse code over here. If you download the source code, you can see there are 2 packages there. Let's say without the inheritance version. Okay. Again, let me just go to resident students over here. You can see that this is how we do the register over here without any constraint. And then let's also open up the definition for non-resident students. Also, the same identical register method without any constraint. Okay. Now, let's say we now change the policy. What we want to do is we want to put some constraint to say if you already registered for 10 courses, you better be stopped. Okay. So I gotta change 2 places, right? I'm gonna say if the number number of courses is already equal to 10, for example, right? In that case, I'm going to say throw new illegal argument exception, okay? I'll leave the error message to you, okay? And then otherwise, we can do normal registration. However, you can see what I just did over here is only the policy change for non-resident students. And resident student is a completely independent class. They have nothing to do with each other. Now, if I really want to make sure the policy has been applied consistently throughout universally, in that case, I got to copy this, go to the resident students, and then paste. So now you can see that I have for applying this single change of policy, I got to apply that to 2 different places because I got 2 kinds of students. If I got 10 kinds of students, I got to do the copy and paste 10 times. Okay? Everybody got the point? Okay? That's another flaw of this design because it violates the so-called single choice principle. Okay, let's go back. Okay, now let's go back there to the slides. Okay, so that's exactly what I said. I just demonstrated it to you. Okay, so you can see that we got to repeat the same code over and over again for all the classes. Okay, so that's not good. And also just another example for you. Let's say now we change the way we calculate the base amount. Let's say we introduce another thing called inflation rate, right? In that case, you got to apply the same changes to both students, right? Again, that violates the single choice principle. Okay, guys, any questions until now? I'll show you even more flaws of this design. So what I just talked about was only at the level of the resident student and non-resident students. Let's talk about another class, which is how do we create a class for student management system, okay? How do we do that? First of all, this is the challenge. How do we define this class such that we can store both kinds of students together? The best you can do without inheritance is by saying, for each kind of students, I'm going to maintain a collection of resident students and a collection of non-resident students. That's the best we can do. Let me show you. And you will see that again, you got lots of code duplication. Okay? Now, let's say we got class student management system here, and then we simply got to declare 2 arrays, let's say, or array list. 2 arrays. One array is of type resident students. Another array is of type non-resident students. Okay? Now, think about, and then we also got to duplicate this kind of measure, right? To say how many non-resident students do you have, and how many non-resident students do you have, right? So 2. And then, if I want to add a resident students, so I simply put parameter over here, and then just do what I did before, right? Just add it. How do I add the non-resident students? It's going to be a very similar method, right? Well, you do almost the same, except that the type of the parameter over here is non-resident students, and the code structure is basically the same. Again, you're repeating so many things. Let's say we want to register a common course for every student, let's say social science or physics, some common course. Now, how many loops do I need to write? Well, you know what, this is a little bit, let's see that, yeah. 2 loops will be intuitive. Of course, you can do 1 loop, but I will just show you. First of all, I need to go over all the non-resident students over there, go through each one of them, and then register them for that. Okay? And then the same loop has to be repeated by saying, I got to go over the non-resident students and then register for them for that. You can see every time we have some operation to be applied, we're going to apply that to every array over there. Now imagine that if we got 10 kinds of students, what do we have to do? 10 arrays over here. If we got 100 kinds of students, 100 arrays. Of course, student management system is a bit small example. You can think about more realistic example later. Okay, again, this also shows again, this first design is not so great in terms of maintainability because when your system gets bigger in the future, it's going to suffer a lot. You got lots of duplication in your code. Okay? Now, any questions before I move on to inheritance? So far, I'm just trying to show you that without inheritance, there will be a certain kind of problem where you got different kinds of entities that you want to create. They do share something in common, but they also have something that's different among each other. But now in this case, how can you create Java classes for them such that you can minimize code repetition? Okay, that's why we're going to learn about a technique called inheritance. Okay, let's see how the inheritance can be defined. Let's talk about conceptually. So inheritance architecture. Architecture simply means what's the relationship between the classes we're going to create. Okay. In the beginning, you might be a little bit surprised. By using inheritance to begin with, we actually need 3 classes. But you will see that the effort, the additional class is actually worthwhile as the system gets bigger. Okay? You want to think about not just current at the moment, you want to think about the future as well. So we got resident students as before. We also have non-resident students as well. And then what we do is we're going to create another class called students. Okay? What this student class will do is it's going to store all the common parts among the 2 students. It's like we'll factor out everything into the single place. Okay? All the common things. And then in the resident students, we're going to define only the attributes or methods that are specific to this kind of students. And similarly, we only define the attributes or methods that are specific to non-resident students in this class here. And then the way we draw the connection between them is by using a tree structure, which we just learned. In this case, it's a binary tree. Okay? So we say that student over here is a parent class. And then the resident students and non-resident student are the 2 children of the student class. Okay? And then the way we build this hierarchy over here is by using the keyword extends in Java, conceptually. But I'm going to show you how you can write the code. Any question about what I just said so far? Okay? But this is the plan. What you're going to see in the next 3 slides, I'm going to show you the code for students, resident student, and non-resident students. You will see that there will be no code repetition, basically, compared with the previous design, because we actually factor out all the common parts into student class. We only repeat it only once. Okay? Let's see that. So first of all, let's talk about parent or superclass. Okay? That's different terminology you can use. First of all, we have a class called students. And then we're going to define all the common parts among the 2 kinds of students, which are, we have the name, registered courses, and number of courses. So these are all the common attributes between the 2 kinds of students. Doesn't matter if you're non-resident or resident. You always have a name, the list of registered courses, or you got a number of courses. Okay? And then we also have some constructor over here. That's also something that's general enough to be reused. I'll show you how you can do that. And for every kind of student to be initialized, you're going to pass a name, initialize the name, and also initialize a course array to be size 10. And then the way you register for every student is also the same. Okay? Just put it in common place. And then also the way we calculate tuition, only part of it is the same. Namely, the base amount part calculation is really the same among the 2 students. Okay? Are we okay so far? Basically, by factoring out the common parts between the 2 kinds of students into a single class, later on, if we want to change anything, go to this class. It's a single place. So it's going to obey the single choice principle I just talked about. Okay? But we'll see that in just a moment. Okay, that's a student class. Now let's see, yes. Yes, exactly. As you can see, there's a comment over here. I'll read it to you. It's called the base amount only. So we don't apply any premium rates or discount rate. Okay, good. Now let's first of all talk about resident students. You realize how easy it will become. You will see no more repetition. First of all, for the resident student here, we want to say this resident student is a child class of the student class we just talked about. The way to do this in Java is extends students. Extends is a new keyword you got to learn, extends. So what this means is, in the superficial level, whatever code, namely the attributes, methods, or constructor, whatever code you define in the student class over here is going to be inherited, or it's going to be accumulated into this class implicitly, which means you don't have to explicitly define those code anymore. It's just available there. Okay? So now, what we can say is, first of all, we declare the only thing that's specific to the resident student. In this case, only the premium rates. That's the only thing that's common. And then we can say now, when we say resident student here, the constructor, The way we can reuse the code before, we can use a super keyword. Okay, super, well, I give you some analogy. Remember we talked about this keyword before. This means the current class. Super means the class that's immediately above you. In this case, the students. So when we say super over here, it's as if we called the student constructor over here. Because we simply say that resident students extends students. Okay? I'm going to draw some picture in just a moment. Okay? And then also we got, now, one thing to know is in comments, we don't have to repeat the register method anymore because it's simply inherited. Okay? And then how do we calculate the tuition? In this case, again, we already inherited the base amount calculation. The way we can refer to it is by saying super. So now super means give me the calculation that's returned from get tuition from the student class, which calculated exactly the base amount, and then I'm gonna apply this base to my premium rates only. Okay? Any questions so far before I draw some diagram to you? Yes? Good question. Good question. The question was, let me draw some diagram. Okay? The question was, let's say if I have something like this. Let me just go to iPad here. The question was, let me just make it a little bit symbolic. If I have class A over here, and then class B over here, and class C over here, right? Let's say class C extends B. Class B extends A. Right? So now, in the context of class C, if I say super, I'm only referring to class B. You might be thinking, can I say super over here, and then I'm referring A? No. You can never refer to that. They don't give you this flexibility. You can only refer to the class above. You know what? You'd rather that they don't give you this flexibility. It can make your code very messy and also very hard to track. Okay? It's a good question, actually. Yeah. Good. Yes? Huh? No, so here, in the context of C, if you say super over here, you're referring to something in B. In the context of C, if you say super here, that means you're referring to it's immediately above parent class, and that'll be something in class A.
So you can still have C extended.
Of course, yeah. Well, what we will see is from Tuesday, we'll see that with respect to certain hierarchy of the inheritance, you're gonna have some certain rules you're gonna follow. Well, we'll get there. Okay, but today, I want to keep it light for the first time. Okay, let's see. Okay, so now you can go over that. That's exactly what I said. Oh, by the way, you can also do other things. You can say super.name, also super.register. Basically, just do the super as if you were this, right? Just when you say super, it refers to the previous class, the above class. Now, how do we define the non-resident student class? Well, you're going to extend also student, right? You're going to say non-resident student here extends students, right? And then you're going to say define something that's only specific to the non-resident students. In this case, discount rate rather than premium rate, right? And then when you define the constructor for non-resident student, again, you can refer to super. Right? Remember the hierarchy, we got non-resident students, resident student, on the top, we got students. You refer to the same student class. And then you don't have to define the register method anymore, it's just inherited. And then we got get tuition here. Just use super.get tuition here again, and then apply the discount rate. Okay? Let me draw a diagram very first to begin with, and then you can ask questions. Now let's go here. Let's review what we have done so far using inheritance. Okay? First of all, we define a class called students. In the student class, nothing special here. We simply define some attribute here. For example, we say string, the name of the students, and also we say course array. I'll say CS for courses. And also we have also integer, the number of courses. So these are the three attributes we define. Okay? And also we got one mutator, which is void, and then register. And also, okay, you define that somewhere. And also you got another one, which is accessor, get tuition. Okay, so this is what you define in the student class. Okay, now, when I say resident students extends students, that's what I said before when I declared this class over here. So what does that mean? That means in the diagram, I'm adding a new box over here, and then it's called resident, I'll just say RS for resident students. And then that one there actually extends. Okay, so you can see that extends. Okay, that's conceptually how you can think of it. Now, what did I do to resident students? Let me just try to use something over here. First of all, it's going to inherit everything that's defined. Okay, so now I'm just going to write them out very quickly. You got name over here, you have courses, you have number of courses, you got register, and also you got get tuition. So these are inherited, and no need to repeat them. Okay, repeat. That's really crucial. Okay, and we also define something that's new. What we define as new thing is premium rates. So we got premium rates over here. Okay, and not only that, what we did was slightly more complicated was we say that even though we inherit the get tuition method from the student class, but we try to use it and redefine that a little bit, add something on top. It's something called override. Override, that's a Java, very Java specific term, or you can say redefine. For any methods that you inherit from your parent class, you can always redefine them in whatever way you like. You can always do that. Okay? Okay. Now, the way we redefine that is by using the premium rates, right? We say base amount, multiply the premium rates. Okay? Guys, any question about this so far? And we did the same thing for non-resident student, the same thing. Okay? Questions? You don't have to. You don't have to. That one is only for the, when you generate the equals method from Eclipse, it does that for you just to be explicit. But usually when you override, just override. Mm-hmm. Okay, good. Let's go back there. Okay, you can read the same thing over here. Okay, that's the inheritance hierarchy we have. Okay, again, so let's learn the terminology. Terminology is going to be very similar to what we learned in the binary tree or trees in general. So we say that student is the superclass or the parent class. Or we say resident students is a subclass or child class. And also ancestor and descendants. We'll use ancestor and descendants a lot for next week. Okay, just make sure to review those terminology from trees. Okay, now, another thing, how do we visualize the parent-child objects? That's also important. Basically, the very superficial understanding about inheritance is about code accumulation. You accumulate the code from your parent class. Okay? How do we do that? Now, first of all, a child class, for example, resident students or non-resident student, they inherit all the attributes from its parent class, or all the methods. And the parent class, in this case, students. Okay? So what's the consequence of that? It's a very important thing. That means any instance of the child, they have at least as many attributes as the instance of its parent class. For example, and I'll visualize that for you in just a moment. So now, let's say we got the following three lines of code. Let's say we have student over here as Stella, and also we have resident students, also Rachel, and non-resident student Nancy. Okay, we got three kinds of students. Now, how do we visualize them at the runtime? So now, first of all, can you take a guess? Well, remember how I actually used to draw to visualize objects. Which object over here has the least number of attributes? S, right? Okay, which one has the most? Now, RS and NRS, do they have the same attributes or they not really? Not really, right? There's some crucial difference there. Let me show you. Okay, once you see the diagram, you will see. Let's go over one by one. First of all, let's look at the top one. Okay, so this is S, which is Stella, students. You can see I put student over here at the title of the box. And then the student has name, number of courses, and registered courses, right? That's a superclass. Now, in resident students over here, it's going to first of all accumulate all the attributes from the parent class. In this case, they also have name, number of courses, and registered courses. But they got something that's specific to it, which is premium rate. Yes?
We only define premium rate in the class.
Exactly. So let me just show you again why this is the case. Let me show you again. Let me just go back there. If you go back to the resident student class, first of all, you can see that we say resident student extends students. That's why it got name, courses, and number of courses. That's what it tells you. But now we are adding something new, that we're accumulating the code, right? Not only that we accumulated what's really inherited from the parents, we add something that belongs to ourselves, right? Good. That's really important, right? Okay, so let's go back to the diagram over here. So now that's why you can see that for resident students, we got actually 4 attributes rather than just 3. That's what I meant by a child instance has at least as many as what's really inherited from the parent, at least as many, okay? Now, for the non-resident student, by the way, there's a typo. There should be Nancy, not Rachel. I'll change that, okay? So now, non-resident student over here, even though it has 4 attributes, but you can see that the attribute that's additional over here is different, right? It's discount rate. So now, in some way, that means you can think in this way. I want to say that very informally. If you think about the object we are drawing here, you can say that S is a subset, is a sub-object of RS and NRS. Because what's really required for S over there will be name, number of courses, and registered courses. And these 3 attributes are available on both kinds of student over there, right? However, you cannot say the other way around. Which means if I want to have a resident student to return back to me, which means for the resident student, I'm expecting some premium rate to be available. In this case, it would not be acceptable if you just give back to me a student objects. In that case, the premium rate is not there. And also, you cannot give me a non-resident student objects because also premium rate is not there. Okay? But we'll actually see that this kind of argument here is very important when you talk about polymorphism and dynamic binding. Okay? We'll get there on Tuesday. But just want to give some informal view. Guys, any question about these diagrams here? That will help you, hopefully, to visualize what's going on at the runtime. Questions? Are we okay? Okay, very good. Now, let me, and so we use inheritance for code reuse. Okay, let me just show you one more thing. Let's go back to Eclipse over here. Let me do a similar exercise over here. Let me just close these 2 classes from before. You will see that there's another package over here called with inheritance. Now, the with inheritance over here, you can see that the resident students actually extends the students. You can see that we did not define any register method here. We did not, because it's inherited. Similarly, in the non-resident student class, we also did not declare that. We did not, right? Because that's also inherited from its parent class over here. Now, let's say this. If I want to apply the same policy change, where should I go? The superclass, right? Yeah. I simply go to student class over here. You can see that this is the only place I gotta go. Okay? You can do the exercise by yourself. That's the only place. You don't have to go to every subclass over there because they simply inherit the same piece of code from their parent class. Okay? Okay, hopefully you get that. Okay, now let me just summarize what I really meant by code reuse for inheritance. Okay, and then we'll do some little bit exercise. Okay. Now, inheritance in Java allows you to superficially. Again, code reuse is the very beginning understanding about inheritance. It's actually much more to that. When you talk about cast, when you talk about generics, when you talk about abstract class in interface, you all require the deeper knowledge about inheritance. That's something we'll focus on next week. So now, first of all, inheritance allows you to define some common attributes and methods in a single class. In that case, it can be just a student class, right? You got all the attributes there. And then you can define some extended version of each of the class using inheritance. For example, you can inherit all the definition for attributes and all the methods. For example, you simply say the resident students extends the students. In this case, the name, registered courses, and number of courses, they're all inherited. Okay? And also all the methods. And also, yeah. Okay, so now what does that mean? That means there's only a single place where you store the code. Only the single place, not really multiple places. Now, this is also very important here. Not only that you can inherit something from your parents, you can also add something additional to yourself, only specific to yourself. In this case, in the case of the resident students, we add a new attribute called set premium rates. Well, premium rates. And also, for the non-resident student, we also add discount rate. Right? Those are specific methods or attributes to the subclasses. And this is also important here. When you inherit something from your parents, if you are not happy with it, you can change that if you want to. It's something called override or redefine. Okay? Again, override is more Java-specific term. If you prefer, you can always say redefine. That might make more sense to you. Okay? Redefine. For example, when we, in the resident student class, when we inherit the base amount tuition calculation from the parents, we can change that a little bit by saying, whatever base amount I got, apply that to the premium rates. Similarly, in the non-resident student class, when I inherit the base amount calculation, I'm going to apply that to some discount rate. Okay. Guys, any questions until now? Yeah. It's a very good question. The question was, on the client side, should they declare a variable of type students, resident students, or non-resident students, right? It's a fantastic question. I'll delay the answer until Tuesday because that involves lots of discussion about typing, okay? That's the fun part of inheritance. That's exactly the fun part. Okay, that's the inheritance hierarchy we have. Now, let me test your intuition. I wouldn't say understanding because up to now, it's kind of difficult to really see what's going on since you only know about accumulating the code, etc. Let's take a guess. Let's now say we got the following three variables. So now I say students S, resident students RS, non-resident students NRS. We got three different variables over here, okay? Now I'm gonna draw a table to explore all the possibilities. Because in OOP, the most important thing you want to be able to do is use a dot notation. S dot something, RS dot something. So these are the possible attributes or methods we may call on these variables. Some of them might compile, some of them may not compile. Okay? So let me just say there's some short form over here. So we got name, we got registered courses, we got number of courses, the register method, the get tuition method, premium rates, set premium rates, discount rate, and set discount rate. Okay, so these are what we have over here. Now, let's see what we can do. Oops, okay. Again, it's really bad. Okay, that's okay. Well, let's try. Now, let's say we're gonna try S first. What can you call on S? First, let's do one by one. Can you say S.name? Because I will give you some intuition. It's very easy to see. We can say S.name because you can see name is defined in the student class. Can we say S.registered courses? Yes. Can we say S.number of courses? Yes. Similarly for register and get tuition. Now, here's the thing. Can I say S.premium rates? The reason is very easy because in the student class, we simply don't have the premium rates available. We just cannot do that, okay? And similarly for discount rate. That's why you will see something like this. Let me just give you a little bit preview of Tuesday. Remember when we talked about the equals method about a month or maybe more than that ago, I talked about something called static type. So now is the time to really talk about static type and dynamic type for in more details. The one I highlighted in green over there, you can see when I say student S, that means I'm declaring a variable of type students. And the student over there is the static type for S, which means it's static, it's fixed, never changed. Okay? Now, to decide if I can call a particular attribute or method on the class, I only look at the static type. Okay, that's a principle. But we'll repeat this principle a number of times. Now, let's try the similar principle here. Now, I'm not going to touch it. So now, if I have the target being RS, can I say rs.name? Question for you. You can see there's no name defined in resident students. Why can I say rs.name? It's inherited, exactly. It's inherited implicitly. Okay, very good. Can I say rs dot register courses? Yes, okay, very good. Okay, so you can see the first column there is fine. Can I say rs dot premium rates? Yes or no? You know, now, give you a hint. Whenever I say maybe, there's no maybe. Science, either yes or no, no maybe, no maybe.
It's private.
No, nothing private, nothing to do with private. The question again, okay. Now, can I say rs dot premium rates? Yes or no? Okay, the way you judge is by looking at the static type of rs. The second line over there, I say resident students rs. Does resident student define the attributes or inherits an attribute called premium rates? Yes. So, yes. Can I say rs dot discount rate? Because that's defined in its sibling, which has nothing to do with them, right? Very good. That's why you got something like that. Now, hopefully you will see that. What about NRS? Hopefully you see kind of this pattern over here. For NRS, again, can we say NRS.name? Because it inherits the name, register courses, number of courses from the parent class. Can we say NRS.premium rates? No, right? Because it's only defined its sibling. Can we say NRS.discount rate? Yes, it's already defined there. Okay, exactly. There's this table here. I want you to remember one thing before you come on Tuesday. I want you to think about this. I'll write it down on the iPad. It's really important. Otherwise, you'll just get lost on Tuesday. So now over here, I want you to, first of all, students, if I declare something over here, student S, of course, I might say something over here to create the object. That doesn't matter. Student over here, again, I call this the static type. Now, static type has a very important functions for the compiler. Static type defines the list of expectation. That would be the word I'm going to use. Expectation on S, which means I can expect to say S dot name. I can say S dot number of courses. I can also say S dot register courses. Okay. I can also say S dot register with some argument here. I can also say S dot get tuition. Okay, you can see that over here, these are all the expectation of S. It's entirely determined by the static type. On the other hand, I cannot do S dot premium rates or S dot discount rates. So these are not expectation of S, because the static type simply doesn't support that. Now, let's use the same analogy of expectation. If I have just another variable, I'm going to put it aside to compare. Okay? Let's say I got over here, if I say resident students, let's say RS over here. Okay, now, question for you. Do you think we can expect more from resident students? Yes or no? What's that additional expectation we have? Premium rates, right? Okay. Okay, so now you can see that over here, RS is going to inherit all the expectation from its parents. Expectation from students. And what's more, we can say some additional expectation. We can say also RS dot premium rates. That's the additional expectation. Additional expectation. Sorry about my writing. Okay, that's additional expectation. So now, another principle for you to really understand intuitively before you come on Tuesday. For any child instances, we can expect at least as much as we do for their parents. In this case, what we can expect from the parents of resident students, which is students, is the green part. But now for the resident student, which is a subclass of students, we can expect at least as much. And more than that, we can also expect resident students. Okay? Guys, any questions? Okay? Now, let me just do a little bit, just give me 3 more minutes, and then I'll finish earlier today. Don't worry. Just give me 2 minutes. I want to just point out to you, the next slide over here is, okay, one more thing. If you try to run the same tester on this new design over here using inheritance, exactly the same test, you will see the right behavior as well. So basically, the first design without inheritance and the second design with inheritance, from the external person's point of view, they're the same. But internally, you want to be as clean as possible. That's why you want to follow inheritance. Okay, that's the point I want to make. And then, what I want you to do also is a self-study. Okay, now just review very quickly. So now for Java over here, we talk about every class is a subclass or child class of the objects. So there is a class called objects. And there are 2 important methods in the object class that's inherited to all the classes. One is called equals, the other one toString, exactly. Okay? So we already talked about these, so there's nothing new here. I want you to go over the slides from here until only a few slides about how you can define the equals method and toString. Okay, hold on. Okay, until slide 29. Okay, now on Tuesday, this is my advice. Sleep well on Monday night because the stuff we're going to talk about next week is going to be hard. But hopefully that'll be rewarding to you. Okay, I'll see you next week.